Okay, so we're going to talk about balancing chemical equations. A chemical equation is a way of representing a chemical reaction. It's similar to a word equation, except that the chemical names have been replaced with chemical formulas. A chemical equation that is complete but is unbalanced is called a skeleton equation. So for example, we have methane plus oxygen reacts together to produce water and carbon dioxide. We can write a skeleton equation by replacing each chemical name with its formula. So we have methane, oxygen, water, and carbon dioxide. However, it doesn't demonstrate the law of conservation of mass. It's completely unbalanced. The law states that the mass of the products, which are right here, must equal the mass of the reactants. So here's our skeleton equation again. If we look at the reactants, the products, and the numbers of atoms of each type, they appear to be imbalanced. Okay, so they're not equal. So if we were to count them up, okay, the reactants, there's 1 carbon and 1 carbon on the other side, so those are equal. The hydrogens, though, are not. There's 4 here and only 2 on this side. And for oxygen, there should be 2, and there are 3 on this side. Since we cannot change the formulas of the molecules, because then they wouldn't be the same chemical, we have to change the number of each molecule. If we add an oxygen molecule to the reactants and a water molecule to the products, this balances the equation. So what it looks like is when we put a 2 in front, we get 2 of those molecules. Okay, so now, if you remember, you count how many atoms it is by the little number, and then you multiply it by the coefficient, the 2 in front. So that means now we have 4. Okay, on this side, for the oxygen, you have to multiply the 1 by the 2, so that gives me 2, plus the 2 over here gives me 4 oxygens. The hydrogen has 2 times 2 gives me 4, so that balances everything out now. An equation in which the reactants and the products contain an equal number of each type is a balanced chemical equation. A coefficient is a number written in the format of a chemical formula or symbol. It indicates the number of atoms or molecules of that substance. So what we're doing is we're taking skeleton equations, okay, and we're balancing them. We're putting coefficients out in front, and we're working on balancing both sides of this arrow. When there's no number written, so for example right here or on the C, 1 is understood. Balancing an equation requires patience, perseverance, practice, and one of the steps or rules will not apply to all equations you're asked to write. But here are some helpful guidelines that might make your life easier. Count the number of atoms on each side of the equation first. So if we were going to do sodium, okay, and what I like to do is I like to start with the metals first and then the non-metals. And if I have oxygen or hydrogen, I do those last. So I have 1 here and I have 1 there. Chlorine, I have 1 here, but I have 2 on this side. Beryllium, I have 1 on the left side and 1 on the right side. And fluorine, I have 2 on this side and 1 on that side. So you can see it's not balanced. The sodium is, but the chlorine is not. The beryllium is, but the fluorine is not. And so that's what we're going to try and fix. Remember, when trying to balance equations, you can only change the value of the coefficient in front of the compound or element, not the subscripts, not the little numbers to the bottom right. Balance the elements that have the greatest number of atoms in any reactant or product, other than hydrogen and oxygen. Leave these last. If you start with hydrogen or oxygen, you'll be chasing your tail. It takes forever, and even I would give up. Okay, so you always start with the bigger elements, and I always like to start with metals first, and then non-metals, ending with oxygen and then hydrogen. It makes your life so much easier. So we want to balance the other elements other than hydrogen and oxygen. Okay, if you get a polyatomic ion, you treat that ion as a unit. You balance oxygen, hydrogen last. All right, we're only gonna do a few of these. We're gonna count these atoms. So we have 2 sodium, 1 carbon, and 3 oxygen. Here we have 3 calcium. And then remember, when there's a 2 outside of the brackets, it multiplies through each of these. So I have 8 oxygens and I have 2 phosphorus. I have 2 potassium, 1 chromium, and 4 oxygen. Now, when there's a number out front, you have to multiply it by the little number. So 3 times 1, I have 1 barium, and I have 6 calcium. Now, for aluminum, I have to take the 2, multiply it by the 4, that gives me 8. And then I have to go and do the brackets here, but first I have to start with this number. 3 times 3 is 9, times the 4 is 36. And then I have to go 3 times 1 is 3, times 4 is 12. Now you can use your calculator. You don't have to do this in your head. Okay, so you can use your calculator to count your atoms. All right, I have 1 lead, I have 2 nitrogen, and I have 6 oxygen. I have 1 nitrogen, I have 7 hydrogen, 2 carbon, and 2 oxygen. And this one's super complicated, and I'm never going to give this to you, these 2 here. 4 nitrogen, 16 hydrogen, 4 chromium, and 14 oxygen. I am not giving you these type here. Okay. All right, so we're going to do a couple examples. Okay, so what we do is we start with the metals first. So what I like to do is I like to put the elements under the arrow sign and then bromium. Okay, and I do a dash on either side, and I'm going to count either side. So on the left side, there is 1 aluminum. On the right side, there is 1 as well. There are 2 bromiums on the left side, but there's 3 on the right. So what we have to do is we have to put a coefficient out so that these numbers are equal, okay? So we need a number that they both go into. Now, if I put a coefficient of 2 right here, okay, that gives me 2 aluminums now, but that gives me 6 bromiums. Now I'm going to put a coefficient out here, and I'm going to put a 3 here, and when I put a 3 there, that gives me 6 bromiums. So now I'm balanced, but now my aluminums are not, so I have to put a number out in front of here so that I can get 2 aluminums. So if I put a 2 here, that gives me 2, and I can see that both sides are equal. All right, let's try this next one here. Okay, so we're going to start with the metal first, sodium, oxygen, and hydrogen. So leave oxygen and then hydrogen last. And we're going to count them up. So on the left side, I have 1. On the right side, I have 1. On the left side for oxygen, I have 1. And I have 1 on this side. On hydrogen, I have 2. And on this side, I have 1, 2, 3. So everything is balanced but my hydrogens. So I'm going to start with that. I need to put a number out front, okay, so that I can equal this out. So it's probably easier to put a number out in front of this one. So if I put a 2 here, that's going to change my sodiums to 2, my oxygen to 2, and I'm now going to have 2 plus 2, I'm getting 4 now hydrogens. All right, let's take a look over here. So I want to balance my sodiums first, so I can put a 2 out here so that I have 2, and now those are balanced. And now I need to get 2 oxygens and 4 hydrogens. So if I put a 2 out front, 2 times 2 is 4, and 2 times 1 is 2, and now that is balanced. Okay, and so that's it. There's a worksheet that goes with this. I'll add a couple of videos to help those that need some extra help. All right, we'll see you soon.